Okay, so last time I explained how the decimal system works, and I basically did this to prepare you guys to understand different concepts that you use in number systems or that we use on a day-to-day basis that we'll also use in hex and binary. So I just want to go over real quick just a few examples of how we use the decimal system again. We've already covered that, so I don't want to go too into detail. But like I said last time, number systems, or especially the decimal number system in particular, the one we use it to represent tons of numbers, right? We have 0 through 9, but we use these 10 symbols to represent an infinite amount of numbers. So we could easily use a different amount of symbols to represent an infinite amount of numbers the same way. So we just randomly chose to stop at 10 because it sounded right to us. So for example, I want you guys to think about how you already use the decimal system. So basically, we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then what do? We go to 10, right? But we don't have a unique symbol for 10. So in order to represent 10, we have 1 and a 0. So if you think about that for a second, why do we use that to represent 10, right? So let me show you something. I'm sure you guys already know this because you guys have taken basic math courses, but remember something called the ones place, or the tens place, or the hundreds place? So those things all exist for a reason. We didn't just come up with the hundreds place to confuse kids, although at the time you might not have really understood why they were talking about this, because it's pretty obvious that this is 110 to us because we're used to using the decimal system. But things are different when you're in a different number system. So basically what this is trying to tell us is that you have 1 100, 1 10, and 0 ones, right? So the thing is that once we get to 9 in the ones place, we don't have a number to represent anything higher than that. So we just denote this to representing how many tens we have, right? So, but we still use the 10 symbols that we have before that to represent how many of those we have. So if we don't have any tens, we could just do 0. 0 represents none, so that's 09, which is 9, right? But let's say we had 2 tens, right? Then we'd be 29. So, and this goes on forever. Like if you get to 99, that means you have 9 tens and 1 9. And you want to go above that. We don't have anything to represent that. That's why we move over to the hundreds place to represent that we have something more than that. And that way we can represent an infinite amount of numbers using just 10 symbols. We can do the same thing with more symbols if we wanted to. So hex works the exact same way. You just count up 0, 1, 2, 3, 4, 5, 6, blah, blah, blah. And then you get up to 9. But in this case, we have more than just 10 symbols. So A would represent 10, 1 after 9. And I guess we just used symbols from the alphabet because we didn't want to make new symbols, so that's whatever. But yeah, so moving forward, and then we got B, which is 11, C is 12, D is 13, E is 14, and then F is 15. So we can represent up to the number 15, which is pretty cool, but once we get there, we have to go over because we can't represent more than that. So the exact same way, we have the ones place, and we have 15, but if we want to go up 1, if we want to add 1 to this, which actually, this is really cool. So if you wanted to do arithmetic, here, I'll just clean this up. So this is the ones place, and this is the 16th place, right? So if you wanted to move over, if you wanted to add 1 to this, basically, so you have 0f, or 15, basically, and you wanted to add 1 to it, you could actually add it the same way that you do using the decimal system. So, I'm sure this looks familiar to you guys. So you got 0f and you got 0, 1, right? So this is 15, and this is 1, but we don't have anything higher than f, right? So we'd end up with, usually, if we were adding 0, 9, this is decimal, to 0, 1, it's supposed to be a 9, we would get a 0 and a 10, right? We'd have 1 over here, and that's 10, right? So we do the exact same thing over here. We get a 0 and a 1, right? But in this case, our 1 represents 16. 1/16 instead of 1/10. So we used to have a tenths place. Now we have a 16th place. So that's pretty interesting. It's pretty cool to think about. And last, probably the most important thing I want to go over is binary. So the reason the binary exists is because we're limited in how we can communicate to computers. So computers only see positive and negative charges, right? So if you have a positive charge, it sees a 1, and if you have a negative charge, it sees a 0. So we invented binaries so that we could represent an infinite amount of numbers with just 2 symbols, which is pretty cool. So for starters, I'm sure all of you know that 8 1s and 0s is a byte. So that's just a measurement of data. And so the binary system works the exact same way that the decimal number system and the hex number system works, is that once you get to the max, so in the decimal number system, once we get to 9, we have to move over a place to the tens place. In hex, once we get to f, we have to move over to the 16th place, right? Because we can't represent anything beyond that because we have a limited number or limited amount of symbols, but we still want to represent infinite numbers. So same thing for binary, except we have to move over almost constantly because we only have 2 symbols. So this would be the 1's place, just like everything, but once we count to 1, if you want to add 1 to that, you can't because we already hit the top. So that means this will be the 2's place. And once you add 1 to that, see we have, this represents 3 because that's 1, 2, and 1, 1. If you want to represent more than that, you have to go to the 4's place because we can't represent any more than 3 with these two. So, and so on. I'm writing 1s in all these. This would be 1, 4, plus 1, 2, plus 1, 1. So, that would be 7, right? So, and then lastly, you got 8. So, what's really interesting, something you want to note here, is that you see you have 8, 4, 2, and 1. If you add all these up together, you're going to get 15. And what's really cool is that in hex, you also can only represent up to 15 with this first letter, right? Before you have to move over. So you could actually easily convert binary to hex. So if this was 15, if all these were 1, that would make the hex number here f, right? That they're the same thing. So, and let's say these are all 0. So that this binary number, let me just finish this. Alright, so this byte is the same as this hex number. So it's really easy to convert between these two, which is why hex actually exists. Hex is something that programmers, or that people, can read easier than binary. Binary, you have to think through. You have to be like, okay, so that's 8, oh, this is a 32, and you have to add in your head. You don't want to necessarily do that all the time. So hex is a lot closer to the decimal number system, so we use hex for programmers to actually think in binary a little bit easier, and you can easily convert back and forth if you ever need to. So that's pretty cool. So anyways, these are sort of like the basics, bare bone crash course to decimal, binary, and hex, and how the number systems relate, and how you might be able to use them. So now you guys should have a better foundation or a better idea of what we're doing when we go into low-level coding or low-level reverse engineering and start working on Space Invaders Emulator. So in the next video, I'll actually start coding. We can write the disassembler for Space Invaders, and hopefully once you guys actually see the code being written, it'll make a whole lot more sense to you. For me, I didn't quite grasp everything until I actually started coding, and honestly, I didn't have a great foundation, so I had to go back and learn this stuff. But once I started using this in my code, everything made a whole lot more sense. So hopefully, same thing will happen to you guys. So check for that video.